Good morning, dear students. Today we are going to solve October-November 2013 2-1 paper. The course we are studying is Physics 5054. My name is Ferhan Mazher. Today in this video, we will be solving only section A of this paper. Section B of this paper, we will solve in another video. Let's start today's paper. Okay, question 1. A swimming pool is filled with 450 meter cube of water at 12 degrees centigrade. The density of water is 100 kg per meter cube and its specific heat capacity is 4.2 joules per gram per degree centigrade. Calculate the mass of the water in the swimming pool. Before we start this question, on your hard copy of the paper, underline this. You can see here that the unit of the mass used in the specific heat capacity is grams. Okay, the A part is calculate the mass of water in the swimming pool. The density is given and the volume is given. You know the density is equals to mass divided by volume. So mass is equals to density multiply volume. So you can put the values of density and the volume and you can multiply them and you will get the value of the mass. And the answer will be in kg. Okay, so I've done this on a paper. Let me show you that on your screen. You can see question number 1A part. Density is equals to mass divided by volume. Mass is equals to density multiply volume. And the density is 1000 kg per meter cube, multiply 450 and meter cube, and the answer will be 4.5 expo 5 kg. Very simple question on the formula of the density. I hope that you have understood it. The B part is on your screen. Calculate the thermal or heat thermal energy needed to raise the temperature of the water to 27 degrees centigrade. So the initial temperature was 12 and we want the temperature to rise to 27 degrees centigrade. The specific heat capacity is also given and we know that when the temperature changes, the formula for the heat is equals to mc delta theta. Now the mass given is 4.5 expo 5 kg. But because in the specific heat capacity, the unit which was used for mass is gram, so I will convert the mass into grams. So 4.5 expo 5 kg, it should be multiplied with 1000 to convert it into grams. And once you have that, and another thing which you should know, the change in temperature. The initial temperature is 12 degrees centigrade and we want the final temperature to be 27. So the change in temperature is 27 minus 12 and that will be 15 degrees. So we will put these values in the formula heat is equals to mc delta theta and we can calculate the heat. I have done this on a paper. Let me show you my working. So it's a 3-mark numerical and let me show you my work. Okay. So on your screen, you can see that heat is equals to mc delta theta and the value of the mass is 4.5 into 5 into 1000. That's for converting the kg into the grams into 4.2 into 27 minus 12. And the final answer will be 2.8 expo 10 joules. So 2.8 expo 10 joules is the energy which is needed to raise the temperature. The next question on your screen is suggest one reason why the thermal energy needs supplied to the water by the heating system when raising the temperature of the water to 27 degrees centigrade differs from the value calculated in the first part. So the value of the heat you calculated required to raise the temperature from 12 to 27 degrees centigrade is 2.8 exposed 10 joules. But in reality, the energy required will be more than this. The reason is when you are heating the water in the swimming pool, the some energy will be lost to the walls of the swimming pool, and some energy will be lost because the process of evaporation is happening, and due to the evaporation, the heat is being lost, the thermal energy is being lost to the surrounding. I've written this answer. Let me show you my answer. So on your screen, you can see heat is lost to the walls of swimming pool and to the surrounding by evaporation of the water. Okay, I hope you have understood. Okay, let's move to the next question. So on your screen, you can see we have a girl of weight 550 Newton is playing on a seesaw with her brother. Figure 2.1 shows her brother of weight W sitting 1.1 meter to the right of the balance point. So here this girl is sitting, her weight is 550 Newton. The moment arm from the pivot is 0.86 meter. Here is the boy, his weight we don't know, it weighs it W, and its moment arm from the pivot is 1.1 meter. The whole thing is in balance. So the anti-clockwise moment produced by this girl is equals to the clockwise moment produced by this boy. The seesaw is balanced when the girl sits 0.86 meter to the left of the balance point. A part is calculate W. W means the weight of the boy. You know, from this figure, I can tell you that because the whole thing is in balance, so the clockwise moment is equals to anti-clockwise moment according to the principle of moments. So we will apply that, and you know the clockwise moment will be W multiply 1.1, and it will be equals to 550 multiply 0.86, and from there we can calculate what is the value of the W. I have done this on a paper. Let me show you that. So on your screen, we have question number 2, A part, clockwise moment is equals to anti-clockwise moment. W into 1.1 equals to 550 into 0.86, and the value of the W will be 430 Newton. I hope that you have understood this. Okay, the next question is a 3-mark question, B part of question number 2. The girl and her brother slide equal distances along the seesaw away from each other. Describe and explain what happens. You see, the weight of the girl is larger than the weight of the boy. The weight of the girl is 550, whereas the weight of the boy is 430. So if they will move equal distances away from the seesaw, the moment of the girl will be more than the moment of the boy. So due to this, what will happen? The Due to this, what will happen? The moment produced by the girl, which is a anti-clockwise moment, will be more than the moment produced by the boy, which is a clockwise moment. And due to this, the resultant moment will be anti-clockwise. It means that the seesaw will tip down on the girl's side. Okay, I've written this answer. Let me show you my answer. And this is on your screen. You can see. I hope you can clearly see. When both moves equal distance away from each other, moment produced by girl will be larger than the moment produced by the boy. The reason is the weight of the girl is more than the weight of the boy. So seesaw will tip down towards left. The reason is the weight of the girl is larger. If the moment arms are equal, then the moment produced by the girl will be more than the moment produced by the boy. So it will tilt to the on the girl's side. Okay, I hope that is clear to you. Now, on your screen, we have question number 3. A schoolboy tries to inflate a bicycle tire using a bicycle pump. Explain how the air molecules inside the pump produce a pressure. You see, inside the pump, we have air molecules. Air molecules are moving randomly and they are moving in all directions. So when they move randomly in all directions, they collide with the walls of the pump. When they collide with the wall of the pump, they exert force on those walls. So that force per unit area of the walls of the pump will create pressure. So this is the cause of the pressure. It's a 2-mark question. I have written the answer. Let me show you. Question number 3 is on your screen. Air molecules are moving randomly in all directions inside the pump. Air molecules collide with walls of the pump. During this collision, air molecules exert force on walls of the pump. Force per unit area is called pressure. So this force which is exerted by the air molecules during the collision, that causes that pressure. So I hope that this idea is clear to you. Okay, so question number 3B part. The opening at the end of the pump is blocked with a small amount of dried earth, as shown in the figure 3.1. So this opening has been blocked by the dried earth, and here we have the piston, here we have pump, inside that pump we have air. The air is initially at the pressure of 100 kilopascal. During one stroke of the pump, the volume of air in the pump is reduced from 120 centimeter cube to 16 centimeter cube. So here, the first part is assuming that the temperature of the air remains constant. Calculate the pressure of the compressed air. You know, the temperature is constant. We are talking about the pressure and the volume of a gas. So we can apply the famous Boyle's law, P1 V1 equals to P2 V2. P1 V1 equals to P2 V2. The P1 value is 100 kilopascal. The V1 value is 120 centimeter cube. The V2 value is 16 centimeter cube, and the P2 is question. So apply that formula, put the values, and get the value of the P2. I have done this on a paper. Let me show you my work on your screen. B first part, P1 V1 equals to P2 V2, 100 kilopascal into 120 centimeter cube equals to P2, which we want to find out, multiply 16 centimeter cube. So P2 will be 100 kilopascal multiply 120 centimeter cube divided by 16 centimeter cube, and the final answer will be 750 kilopascal. I hope that you have understood this numerical. It was a 2-mark numerical. Compressed air in the pump at this pressure exerts a force on the dried earth. The cross-sectional area of the opening at the end of the pump is 1.2 x power 5 minus 5 meters square. Calculate the size of this force. We know the pressure of the air, and we also know the cross-sectional area, and we want to find out the force exerted. The formula for the pressure is force divided by area. And if I want to calculate the value of the force, it will be force equals to pressure multiply area. So I know the pressure, that is 750 kilopascal, and I know the area, it is 1.2 x power minus 5 meter square. But when you will put the pressure in this formula, don't put the pressure in kilopascal. Convert it into pascal. How you will do that? You will multiply it with the 1000. So let me show you my work. Okay. So B second part is on your screen. Pressure is equals to force divided by area. Pressure is equals to, force is equals to pressure multiply area. Pressure is 750, 10 raised to power 3. 750 x power 3 multiply 1.2 x power minus 5. And the final answer will be 9 Newton. So the force exerted is 9 Newton. Here the pressure, we have not taken the pressure in kilopascal, but in pascals. I hope that you have understood. Okay. So that was a 3-mark question. No, we have the third part. Sorry. In fact, the temperature of the air in the pump increases as its volume decreases. We assumed in the previous part that the temperature remained constant, but now he's saying, in fact, the temperature of the air in the pump increases as its volume decreases. The actual pressure of 16 centimeter cube of the air differs from the pressure calculated in the first part. We calculated that the pressure will be 750 kilopascal. Using ideas about molecules, state and explain this difference. So the actual pressure will be more than 750 kilopascal. What is the reason? You know, if the volume decreases and with it the temperature also changes, now you see the air molecules will be moving at a higher speed because you have given them temperature. So they will be moving at a faster speed. So they will have more kinetic energy in them. So what will happen, because they are moving faster, the volume has decreased, their collision frequency with the walls of the pump has increased. Plus, because now they have more kinetic energy, when they collide with the walls of the pump, they exert more force. So their collision frequency has increased and they are exerting more force on collision when they collide with the wall of the pump. So the pressure of the gas inside the pump will increase. So these are the reasons. I've written this answer. Let me show you that answer. It's a 3-mark question. Here we go. If temperature rises, air molecules will move faster. Their kinetic energy will be more. Their collision frequency with walls will increase. And air molecules will exert larger force on walls when they collide with walls. So the pressure of the air will be more than 750 kilopascal, the value which we calculated in the first part. I hope that the concept and the wording is clear to you. Okay, let's move to the next question. Here we go. They say figure 4.1 shows food being cooked in an electric grill. So here in this diagram, you can see we have red hot heating elements. They are here. And the food is below the grills or heating elements? He says the first question is, there are red hot heating elements above the food and thermal energy is transmitted to the food by radiation. Explain what is meant in this case by radiation. In this case, the word radiation means that the transfer of heat by the infrared rays. Radiation here means the transfer of heat by the infrared rays. Infrared rays are part of electromagnetic spectrum, and you know infrared rays have the wavelength less than microwaves, but its wavelength is more than the visible light. Infrared rays, their frequency is more than the microwaves, but its frequency is less than the visible light. So here the radiation means the transfer of thermal energy by the infrared electromagnetic waves. I've written this answer. Let me show you my written answer also. So here we go. Question number 4, A part. Heat is transmitted by infrared electromagnetic waves. Infrared has a wavelength longer than visible light, but less than microwaves. Infrared has frequency more than microwaves and less than visible light. So I hope that you have understood this. Okay. The next question on your screen is, explain why very little thermal energy is transmitted to the food by, the first thing is conduction, and the second thing is convection. Let me show you that diagram and then we can talk. So he's saying that most of the energy transferred, the heat energy transfer from these heating elements to the food is by radiation. Very little amount of heat is transferred from these heating elements to this food by the process of conduction and by the process of convection. The reason for the first thing that why very small amount of heat is transferred by conduction, the main reason is you can see that these are heating elements and the food is here, and between the heating elements and the food we have air, and air is a very bad conductor of heat. And because the air is a bad conductor of heat, that's why a very small amount of heat is transferred from these heating elements to the food by the process of conduction. Because the air present there, air is a bad conductor. In the second part, he says why very little amount of heat is transferred by convection. By the process of convection, mostly the heat is transferred, or thermal energy is transferred in the upward direction. But you can see that the food is here below the heating elements. So the transfer of heat by convection in downward direction is very unusual. The heat normally goes in upward direction. So that is the reason, because the food is below the heating element. That's why by the process of convection, very small amount of current is being transferred to the food. I've written this answer. Let me show you. For the first part, air is a bad conductor of heat, and air is present between grills and food, or heating elements and food. In the second part, he says, by convection, heat is transferred upwards. Food is below the heating elements or the grill. So that's why the chances that heat will come down due to the convection is very minimum, sorry. Okay, the next question on your screen is, I hope that this question is clear to you. Okay, we have reached question number 5. It says, let me try to show you. Draw a labeled diagram to show the structure of a liquid in glass clinical thermometer. Draw a labeled Draw a label diagram to show the structure of a liquid in glass clinical thermometer. Okay, I've drawn this figure. You can also draw this. Here, I've shown it's a clinical thermometer. Here is the bulb of the mercury. Here we have that capillary tube, and here we have a U-shaped band. This U-shaped band is called constriction, and this is that capillary in which the mercury moves, and this is the outer glass of the thermometer. So this is the basic shape. A little bit labeling is also done on the thermometer. I hope that you can draw this. The special thing is this constriction. A clinical thermometer is used to measure the temperature of a patient. When removed, the thermometer cools, but it continues to show the maximum temperature reached. Explain how this happened. Okay, it's a 2-mark question, due to this constriction, when you will put the thermometer in patient's mouth, the mercury will expand and it will come in this capillary and it will show the temperature of the patient. But when you will take out the thermometer from the patient's mouth, the temperature will fall. The temperature of the surrounding of the thermometer will fall. So this mercury, which is in this capillary, will try to go back. But due to this constriction do not let this mercury go back immediately. So what happens that for some time, the mercury will continue showing the maximum temperature it has reached. The thermometer will continue showing the maximum temperature it has gained or read or measured, because this constriction will not let the mercury go back. So you will get ample time to read the temperature. Once you are done with this, so you must have seen that whenever the nurses or doctors or any paramedic staff, they want to take the temperature, first they give the thermometer a jerk like this. So what they do, basically, they give a jerk. The reason is because if the mercury is trapped in this constriction or it's showing a high reading, so by giving a jerk, the mercury goes back to the bulb. So this constriction will not let the mercury come back to the bulb immediately when the temperature of the thermometer drops. The thermometer continues showing the maximum temperature it has measured. So you will have ample time to read that temperature. I've written this answer. Let me show you. Let me show you my written answer. Question number 5B part is constriction in the clinical thermometer do not let the mercury go back to bulb when temperature drops. This gives ample time for reading the maximum temperature gained by the thermometer. Okay. Question number 6 is on your screen. Suggest a material that is used to make a permanent magnet. The most famous material which we are using to make permanent magnets is steel. So I will write here steel. The next question is the B part, and he says, when there are no other magnetic fields present, the needle of the plotting compass points due north in the Earth's magnetic field. This is shown in the figure 6.1. So if the north is in this direction, the needle of the compass will be this side of the needle of the compass, this shaded side of the needle will be always pointing to the north if there is no other magnetic field around. The plotting compass is placed close to a permanent magnet, first at position A and then at position B as shown in the figure 6.2. So here we have a permanent magnet, here we have the North Pole. I place the magnetic compass here, so when you will put the magnetic compass here, because the magnetic lines here, the South Pole is, So the magnetic lines are going into this pole, this end, because here we have the south pole. So the magnetic compass will point in this direction. If you put a magnetic compass here, because here we have the north pole of the magnet, so from here the magnetic lines are going out. Okay. So if I put a magnetic compass here, the pointer of the magnetic compass or magnetic needle will be pointing to the right. Okay. The magnetic field close to the permanent magnet is very much larger than the magnetic field of the Earth. On figure 6.2, draw needles in the two circles to show the direction in which the compass needle points when the compass is at A and at B. Describe. Okay, so I have done this on a paper. Let me show you the diagram on your question number 6A part is on your screen. You can see that I have shown the position A. The compass will be pointing in this way because here we have the south, and here on this end we have north. So the magnetic compass needle will be pointing to the right, like this. I hope that this is clear to you. Okay. The next question on your screen is a 3-mark question. He says, describe an electric method that is used to demagnetize a permanent magnet. You may include a diagram in your answer. So what you will do, you will take a permanent magnet and for example, you have permanent magnet. Permanent magnet is in rod shape. So then what you will do, you will wind it in a copper wire, like a solenoid. So wind a copper wire around that permanent magnet and connect that the ends of the solenoid with a alternating power supply. Now switch on the current and keep the current to its maximum value for some time, and then gradually reduce the current of the power supply. And at the end, you will observe that when you slowly reduce the current and then you switch off the current, then take out the magnet and do the test to check whether it's magnet or not, you will observe that it has lost its magnetism. It has been demagnetized. So the points are that what you will do, you will take a solenoid. Solenoid is a coil, and you connect the coil with a switch and with a alternating power supply. You put the permanent magnet in the solenoid, and for some time keep the current at its maximum value, then reduce the current slowly, gradually decrease the current, and then at the end stop the current. And then take out that bar magnet and check it. It would have lost its magnetism. So you see, this is how we demagnetize permanent magnet. Okay. So it's a 3-mark question. I hope this is also written in your textbook, Physics Matters. From there, you can also see the demagnetization method done by the alternating current. From there, you can write this answer also, and you can also draw the. And here he said you may include diagram. So by taking that book, you can, from the book, you can make that diagram. So let's move to the next question. 9.6 kilowatt electric shower is powered by a 240-volt main supply. Calculate the electric current in the heating element of the shower. The power is given, the voltage is given, and we want to find out the current. You know the power formula is P is equals to IV. P is equals to IV. So if you want to find I, so I will be equals to P divided by V. So just put the values, you will get the answer. But there is one problem, that the power is given in kilowatts. So we don't take the power in kilowatts, we will take it in watts. So P is equals to IV, I will be equals to P divided by V, and the power is 9600 watts, and the voltage is 240 volt, and the answer will be 40 amp. Next question is, suggest an appropriate rating for the circuit breaker in the circuit for the shower. The current taken by the shower is 40 amps. The electric shower, it's taking 40 amps. So the circuit breaker should be more than 40 amps. It could be 41 amps, 42, 43, 45. I've written 50 amps. It should be more than 40 amps because it will taking 40 amps when it's working normally. So the power rating of the circuit breaker, the rating of the circuit breaker should be more than 40 amps. It could be 41, it could be 45, it could be 50 amps. The next question is, a family uses the shower for a total time of 25 minutes every day. The cost of 1 kilowatt hour of electric energy is 21 cents. Calculate the daily cost of using the shower. It's a very simple question. The cost of electric energy, the formula is power multiplied time multiplied price of the 1 unit. But in this formula, the power should be taken in the kilowatts and the time must be taken in hours, and the price is already given here. The power given is already in kilowatts. The time is in 25 minutes, so do you have to divide 25 with 60 to convert it into hours. And then you can put that formula and do the calculation. I've done this on a paper, let me show you. Okay, question number B part is on your screen. Cost is equals to power multiplied time multiplied price per unit, and the power is 9.6 kilowatts, the time 25 minutes, but I will not take time in minutes. I will convert it into hours. So how I will convert it into hours? 25 divided by 60, and you will multiply it with the price of the 1 unit. So the final answer will be 84 cents. 84 cents. I hope that you have understood it. Question number 8 is on your screen. A radioactive sample emits only beta particles and gamma rays. Describe with the aid of a labeled diagram an experiment that shows that sample does not emit alpha particles. Okay, so what you will do, you will take a GM tube and note down what is the background radiation. Check what is the background radiation. Then put the sample in front of the GM tube. The distance between the GM tube and the sample should be just few centimeters. Okay, because the alpha particles, if they are present there, they cannot penetrate more than 5 or 6 centimeters in air. So for precaution, you should put the GM tube just few centimeters away from the sample and note down the count rate on the GM tube. Now, put a paper between the sample and the GM tube and check what is the count rate. If there is no change in the reading on the count rate, it means that the alpha particles are not being emitted from the sample. Because the alpha particles, they cannot penetrate through the paper. So when I will put a paper between the sample and the detector GM tube, if the alpha particles were present there, the reading of the count rate will it should drop. But it has if it has not, it means that the alpha particles are not emitted by this sample. I've written this answer. Let me show you. So this is how you will draw a diagram. This is a lead box, and this lead box I put a sample a few centimeter away. I put a GM tube. It's a detector, and first of all, you will take the reading of the sample and note it down, and then you put a paper between the sample and the GM tube, and you will observe that there is no significant change in the reading on the GM tube. This shows that no alpha particles are being emitted by this sample. So let me read my answer. Take background reading with the help of GM tube. Put sample in front of GM tube and note the count rate of sample. Distance between sample and the GM tube should be only few centimeters. Then put a paper between GM tube and sample and note count rate. You will observe that there is no change in the count rate. This shows that sample is not emitting alpha particles. I hope that you have understood. The spelling of their hairs, I by mistake wrote the other there. Please change it. I hope you have understood it. Okay. Let's move to the next question. So that was a 3-mark question. It's a 2-mark question, sir. State 2 safety precautions that must be taken while working with the radioactive samples. There are many precautions which you should take. Here he's only asking for 2. One famous safety precaution is that you should be wearing lead lining clothes. You should be wearing lead lining gloves. Your exposure time should be very minimum. You should try to keep your exposure time to this radiation minimum. You should be wearing a badge which shows how much is the exposure. And another thing you can choose, do not touch the sample directly. You can use forceps, you can use tongs and to handle the radioactive sample. I've just written two answers. Wear lead clothing and minimize the time of exposure. So that's it. By this question, we have reached the section B. Section B of this paper we will do in another video. So my dear students, today we have done October, November and 2013 paper. The number of the paper is 21. The course we are studying is Physics 5054. My name is Ferhan Mazher, and I hope that this video is helpful for you. It will help you to improve your answering skills and your concepts of physics. Thank you very much, everybody. Have a good day, and God bless you.